Hello everyone, and welcome back. In this video, I'm going to be talking about the concept of optimization. This is going to be just a really brief introduction, and we'll use an example to really help us understand the concepts, to really understand what's going on in a problem like this one. So what does it mean to optimize? You might have heard the word before, maybe not in a math context, maybe in another context. So in general, optimization means to pick the very best of something. It means to alter the conditions of a situation to get the absolute best outcome possible. And in algebra, it's also very similar to that expression, that definition of the word. Except this time we have very detailed things that we're trying to optimize. We have very detailed variables that we're trying to modify to get the outcome that we desire. So for example, we have the fact that we're trying to optimize an expression, and in this case we want to maximize it. And optimization can be minimizing or maximizing. So in this case, we want to maximize the following. We want to maximize 3x plus 2y. And to do so, we have some inequalities to go along with that. These are the constraints. So we have three constraints, and they just give us additional limits that we have to consider when we're trying to maximize 3x plus 2y. And I feel like it's best to illustrate this within a graphical context. So let's graph these three inequalities. And I've already solved these for y, and now I just want to graph them now that they are in slope-intercept form. So we have the line y equals -3 along the bottom. And then we have a line going up like this, and then another one exhibiting similar behavior. So I've just graphed all three of our constraints, and we know how to decide which region to shade in an inequality like this one, or a system of inequalities. So I've already done that. I already did this ahead of time. I already know that the region we want to shade is right here in the middle. This triangular region formed by the intersection of our three inequality lines. So what this means is that we cannot pick a value outside of our triangle. We can't pick this, for example, or that. Our values must come strictly from inside the triangle. So now it becomes a question of which of these would produce the highest value of 3x plus 2y. And just to show you exactly what I'm talking about, if we picked the origin, x is 0 and y is 0, we get 3 times 0 plus 2 times 0, and that gets us a grand total of 0. So probably not the best point to pick. We are trying to maximize this. On the other hand, if we pick maybe x is 1 and y is 1, we get 3 plus 2. Originally we had 0, this one we have 5. So as you can see, this is bigger than the last one, but not quite as big as we can get. Our goal is to make this quantity 3x plus 2y as big as possible without leaving the triangle. So the thing about problems like this is that the endpoints produce optimal conditions. The intersections produce really, really good candidates to decide which would be a maximum. So it has to be one of these three. We always pick the vertices of our intersections, which would be these three right here, the three vertices of the triangle we formed. So this just turns into a question of which one produces the greatest sum of 3x plus 2y. But before we even get there, we need to find these coordinates. We need to figure out the actual values that x and y have at all three of these locations. So from here, it's just simple algebra. We know that this line is y equals -3. So we know that this has an x coordinate to go along with the -3, which is our y, and then same thing with this one. So now it's just a matter of finding the x's to go along with those -3s. So what we want to do is we want to plug in -3 for y into our first inequality up top. We get 4x plus 3 times y, so 3 times -3. And in this case, we're not going to make it an inequality. We're going to just make it an equal sign, because we only really care about this being a line in the intersection of this line and another line. So from there, we only really need an equation. We don't need to express that as an inequality to find x. So now what we have is we have 4x minus 9 equals 21. So let's go ahead and add 9 to both sides. So we get 4x equals 30. And then if we were to divide by 4 and simplify, we would get x is 15 over 2. So that actually pertains to this point right here. This point is going to have, the coordinates of this point are going to be 15 halves and -3. So now we want to do the same thing with our other point on the line y equals -3. So we're going to need to use our middle inequality there to get our value that we're looking for. It's an identical process. We're going to have 2x minus y, and in this case our y is still going to be -3, so we have 2x minus -3. And then again, we're going to make it equals this time. Equals -2, and then we can solve for x. So we can start by adding 3 to both sides. Or sorry, we can start by subtracting 3, because what we really have here is we have +3. So now we have 2x equals -5. So then if we were to divide both sides by 2, we would get x is -5 halves. So this would be the x coordinate of our other point along the base of this triangle, -5 halves, -3. So now let's go ahead and find the coordinates of our topmost point. And we can accomplish that by taking our topmost two inequalities, create equations out of them, and then solve it like a system of equations. Use elimination or substitution to find the solution of the system. We don't need this part below anymore. So now it's just a matter of creating and solving a system. So I want to take our top inequality and solve for y. But before we do that, let's create an equation instead of an inequality to model the information. So let's solve for y. We can subtract 4x from both sides. We get 3y is 21 minus 4x. And then from there, we can just divide everything by 3. So our equation becomes this. We have y equals -4x over 3 plus 21/3, which is 7. So this is our first equation. Now let's find what the other one is going to be in terms of y. Not in terms of y, but in terms of x. We want to solve for y, which leaves an equation in terms of x. So we have 2x minus y. Again, it's going to be equals -2. We can subtract both sides by 2x, we get negative y equals negative 2x minus 2. So then y has to be 2x plus 2. So now that we have both of our equations, we can use substitution to solve the system, find our initial value of x. So this is just a review of the commutative property. If a equals b and b equals c, then the commutative property of algebra tells us that a has to equal c as well. And this is a similar concept because y equals something and y also equals something else, which means the something has to equal a something else. That's the commutative property. So now we just want to find our value of x. So we can start by multiplying everything by 3. Personally, I just don't like having fractions in my algebra. It makes it easier just to eliminate them outright. So I'm going to multiply all 4 of our terms by 3. We get negative 4x plus 21. And then from there, we want to move this 4x to the other side through addition. And I appear to be running out of room, so I'm going to take this, I'm going to move it over here. Same thing with this one. So we have 10x plus 6 equals 21. But then I also want to subtract 6 from both sides, eliminating the 6 on the left side, eliminating the negative 4x on the right side. So we get 10x equals 21 minus 6, which is 15. So let's divide both sides by 10 and then simplify. So we get x would be 3/2. So from here, we just want to plug it into either of these equations to find the y to go along with it. I think I might plug it into our top one for simplicity reasons. Y equals 2x plus 2. Two times x plus 2, so that's 2 times 3/2 plus 2, which gives us 5. So when x is 3/2, y has to be 5. So we've successfully found our topmost point. We found the highest vertex of our triangle. All right, so we've already done most of the heavy lifting. Now it's just a matter of testing each of these 3 vertices to see which one produces the higher quantity. See which one has the highest value of 3x plus 2y. So let's start with our top one. We have x is 3/2 and y is 5. So let's label these maybe point A, point B, point C. Point A, we have the following. We have 3 times x, so 3 times 3/2, plus 2 times y, so 2 times 5. And then we get, this would be 9/2, which is 4.5. Plus 10, so we have 14.5. We want to do the same thing for point B. So for point B, we have x is negative 5/2 and we have y is negative 3. So we have negative 15 over 2 minus 6. Negative 15 over 2 is negative 7.5. So we have negative 7.5 minus 6. And then from here, we don't even really need to simplify this. We know we're trying to maximize. This is a negative number. Our last one is positive. So automatically, we know just between the 2 of these, this can't be the maximum. So now we have one more point to test. we have x is 15 halves, and we have y is -3. So it's structured similarly to the last one we had. So we have 15 times 3 is 45. 45 over 2 is 22.5. So we have 22.5 minus 6, which yields 16.5. So this is our answer for this one. So we know B is eliminated. It's a choice between A and C, so we can see clearly that our winner is C. The quantity presented in part A yields 14.5, and then in part C we get 16.5. So clearly we can see that this is the true maximum. But sometimes in the book, in the textbook we use in this class, they prefer the improper fraction format, so we can get that as well. I just want to write this up here just to highlight that this is our winning number. This is our answer, but I also want to put it into an alternate form. So we have 45 over 2, and then we have minus 6, but 6 is the same thing as 12 over 2, so we could treat this as if it were -12 over 2. 45 minus 12 is 33, so our answer, 16.5 is correct, but 33 over 2 is also correct. Just want to put them both here to show that they are different versions of the same value. And there you have it. That's our answer. So just a quick recap. We graphed the system of inequalities. We did some quick algebra to figure out which region we want to shade. We found out that we want to shade inside this triangle. And then we just briefly discussed conceptually what's really going on. We picked certain test values, and we determined that these endpoints are what really give us our maximum. We could pick maybe something down there, we could maybe pick this one, but we won't get a true maximum unless it's one of these 3 endpoints. So we've identified that point A yields the highest quantity of 3x plus 2y.